ln x minus ln x minus 12 equal 25. Now the left-hand side, on the left-hand side of the equation, we have two ln. So now we condense these two ln into a single ln, and then we can solve for x from there. Since there's a minus sign here, that means we go with the quotient rule. So when you have the quotient rule, it comes with a fraction form. The first term go to the numerator. The second term go to the denominator, equal 24. The next step, we get rid of the ln. And the way we can get rid of ln, we raise up e to the both sides of the equations. Now e ln cancel out. The right hand side it has e to the power 24. Keep in mind this is a numerical number. It's a number. So we just treat this as a number. Now we can use a diagonal butterfly to multiply. So x multiply with the bottom number 1, which is x minus 12. I'm going to run it. Multiply with the e to the power 24. We have 1x here, so we need to distribute here first. So x multiply with the e to the power 24 minus 12 multiply with e to the power 24. And left hand side has x. Bring this term to left hand side. So you have x minus x multiply e to the power 24 is equal to negative 12 multiply e to the power 24.
You'll need to unlock your iPhone first.
Now, since I have the x term, they are the common factor. X is the common factor. So I'm going to bring the x to the outside. And then the first term turn to the 1 minus e to the power 24 equal negative 12 times e to the power 24. Now we divide by 1 minus e to the power 24. Do that to the both sides, and then it will reduce. And then your x is equal to negative 12 multiplied by e to the power 24 divided by 1 minus e to the power 24. When you input this number to the calculator, it will give you a number 12. Now we solve for the x is equal to number 12, right? Logarithm equation, every time when you solve the variable, you need to bring the answer go back to do the test, even though your solution is a positive number. Now, 12, x equal 12, when we have the 12 here, this is okay. ln 12, this is good. On the second term, 12 minus 12, it will turn to ln 0. From the last section, I told you all, when the variable solve it, when you plug in the variable back to the equation, when you get a negative value, we have to discard the solution. And when you get a 0, we have to discard the solution as well. So we don't want to get a negative number. We don't want to get a 0. So when the solution you solved and plug in back here, when it turns to a negative number or a 0, you have to exclude the solution. So 12, even though we solve for the 12, but we cannot take it, so it turns to the undefined or no solution. Probably we'll put a no solution. All right. We do the third equation here. I have the log here. So combine these two log into the same side. So log 1 over x equal 4. Use a property with the quotient rule. So it turns to the log x over 1 over x equal 4. X over 1x means x squared. And you still have the log here equal 4. The next step is get rid of the log. And the way we can get rid of the log. I'm going to raise up 10 on both sides because I don't see the base number here. So this 10 will cross out with a log. And your x squared equals 10 to the power 4. 10 to the power 4, I can rewrite into the 10 to the power 2, and outside has another 2. So that indicate your x is equal 100, 10 to the power 2. When I have a 100 plugging back to here, 100 here, this is good. 1 over 100, it's good. It's a positive number. So we can take the solution of x equal 100. I hope that makes sense to you. Now we do some practice from your homework. Find the exact solution to the exponential equation. We need to find the x. This is exponential equation. Don't swing the 7x to the front, okay? Because you don't have the logarithm or you don't have the ln. You don't swing. You don't use any of the property. The only way we can solve for x, we divide by 2 first. Now your left hand side has e to the power 7x equal 8. X is on the top is the unknown degree power part. So we need to pull down the x by using the logarithm property. Since you have the basis e, I'm going to raise up ln on both sides. And then ln and e will cancel out. So now your left hand side has 7x left equal ln 8. ln 8 is a numerical. So your x is equal ln 8 over 7. Exponential equation, you don't need to do the test. It's only the logarithm equation. So this will be the solution. Solve for this equation, solve for x. Alright, solve the equation. If an answer is not exact, give the answer in decimal form. Round to 4 decimal places. And the hint it gives us here is 5 to the power x plus 3 is equal 5 to the power x multiplied with the 5 to the power 3. So that means at this term, we need to rewrite it into the 5 power x multiplied with 5 to the power 3 plus 5 to the power x equals 630. Now here, 5 to the power x, it occurs for both terms. It has the 5 to the power x. So we can treat the 5 to the power x as a common factor. So now your first term, you still have 5 to the power 3. The second term, it turns to the 1 because you take out the 5 to the power x. It's equal 630. 5 to the power 3 is 125 plus 1, you have 126. And the left hand side, you still have the 5 to the power x. Now we divide by 126 to the both sides. So it will cancel out here. Now we clean up the equation into the 5 to the power x equals 630 over 126. In order to solve for x, we need to go with the logarithm property. Now I'm going to raise up log 5 to the both sides. So we will have the log base 5 and the log base 5 here. Now log base 5 will cancel out with the 5. So your x is equal log base 5 of 630 over 126. Now you can input this number to the calculator. Then it give me the 1. This is an exponential equation. So 1 is the solution. You don't need to do the test. So now we solve for this equation. It has a log 5x plus 4 over 4 times x plus 9 equals 0. So since it's a single logarithm already, we can simply to get rid of the log. Once the log disappears, we can solve for x with an easier approach. So the way you can get rid of the log, I'm going to raise up 10 on both sides. So this 10 will reduce with the log. Now we clean up the left hand side. 5x plus 4 equal 4 times x plus 9 is equal 1 because 10 to the power 0 is equal 1. Now we use a diagonal multiply. You have 5x plus 4 is equal 1 multiply 4, you still get a 4. So you have x plus 9. Now you have 5x plus 4 is equal 4x plus 36. Your x equal 32. This is a logarithm equation. You need to do the test. When I have the 32 plugging back to here, I get a positive number. 32 plugging into the denominator, I get a positive number as well. So this is a solution. We try this one. Right, this logarithm form, we have a 2, right? So I'm going to swing this 2 to the power part first. So we have log base 5 of x squared minus log base 5 x minus a. I'm going to bring this term to the left hand side as well. 10 to the minus log base 5 of 2 equal number 2. Now I have the 3 log. We need to condense this 3 into a single log. So these two, we go with the quotient rule. So we have the log base 5 x squared over x minus a. Now minus log base 5 of 2 equal 2. Condense these two into a single log one more time. So you have the log base 5 x squared over x minus a, and then over 5 to the power 2 equal 2. So now we clean up this part. When you have the fraction divided by fraction, we go with a keep, change, flip, right? So you keep the numerator. Let me write down here. Keep the numerator, which is x squared over x minus a. Change the division into the multiplication, and then you flip the bottom part. So 5 power 2, when they got flipped, it turned to the 1 over 25. So this part, it turned to the x squared over 25 times x minus a. So let me use another color. Now we have log base 5 x squared over 25 times x minus a is equal to. The next step is get rid of the log. I'm going to raise up 5 because the base is 5. So this 5